Chapter 3B, our job this week and our BABAB week is 3, 6, 3, 7, and to get to the review. But next week, I want to start on Chapter 4. Uh-oh! What's the dilemma with me doing that, guys? This week, we're finishing Chapter 3, review day, work day, and then I'm starting, what should be happening on our next class time? A test. Having an entire test on Chapter 3B, not cool. It's not cool. Like, it'd probably be smart, but it's not cool. Since it's not cool, since it would be overwhelming, since it would be kind of brutal, I'm deciding to do a quiz instead, and I'm making it a quest instead, and I'm making it online, have it done by the time we get back. Remember, Monday is a holiday, right? So we don't have class again until Wednesday. Let's be honest, how many of you guys would have been ready for a test after all those days away anyway? It just wouldn't have been great, it wouldn't have been good, and I don't think it would be helpful. So instead, I have a Chapter 3B quiz quest on WebAssign that I will open up like halfway through class on Friday, and then it'll be available throughout the weekend, the long weekend, up until Wednesday morning, 8 a.m. Is that cool? Yeah. Does that make sense? I should say, does that make sense? I should say that, but yeah. And I am going to have all of your numeric values be different. This makes sense, right? The questions will all be the same, but the numbers will be different, and you are allowed to collaborate. Is that cool? Technically, the one time you could come ask me clarifying questions, I will not do a problem for you. I will not find your mistake. I will not, it's not fair for one person to be able to come in after school on Tuesday and other people to not to. Or next Wednesday, is that 0 period day? AB, yeah, next Wednesday will be a 0 period day. Like, some of you just can't make it those times, so for me to give, teacher help is kind of brutal, but I can, clarify a question, or I can, give a hint as far as the overall direction. Just we're not going to specifically troubleshoot until you turn it in and your submissions are set. Does that make sense? Okay. I will go ahead just because WebAssign, there have been a couple annoying things with, I think, was it section 3.5 or was that with pre-cal? There was something kind of annoying, so I'm going to make it 2 submissions. Okay, just in case something's weird or you forget to, I don't know, put an x equals or a y equals. I'm not sure exactly what it could ask. I'm thinking asymptotes or intercepts or something. Sometimes it's weird. You tend to write something wrong. So I will make it 2 submissions. But anyway, that's our goal. Our goal is to get everything done this week, to get some review/work day going on. So in your AP classroom, you guys are going to see a few different things coming up, like, where are we? Here we are. Your 3.7 hasn't even shown up because our job is to finish 3.6. Your CalcAB practice is due today by 3:30, so we are going to pop over there and see if you guys have any questions on the CalcAB practice. It is the thing that is due immediately. So that might be the very first thing for you guys to sign into is into Con. And then we do have the WebAssign, and then you're having 3.7 pop up. The test review is going to be bonus because it's just on Chapter 3B and because you guys have your homework over the weekend is to do the quest. So I didn't want to pile that on top. But, I mean, some test review problems where you can check the answers, etc. might be a good idea. Although the link for that's missing. I'll make sure I get that link up there with the document and with the answers. That's a little bit annoying. So a lot of things are going to be popping up on Friday, like a review test bonus. If you want me to open that earlier, I can, but I'm assuming that we're going to be finishing up the sections up until Friday. So Friday, you'll have a test review bonus that pops up. We can work on in class a bit after covering homework questions, 3.7. There's going to be a note check thing where you can get your notes checked this Friday, or you can get them checked next Wednesday. Just get them checked. Yeah, I think I have it until Wednesday, 3:30. So get your notes checked so that we can get into Chapter 4. He's here. And then here's the quiz that's going to be showing up on Friday. You guys can catch up Noah. I'm going to pause the record on Wednesday, so this is immediately practical. Okay, so the organic chemistry tutor. Lucas already mentioned hey, his explanations are good, but it's kind of annoying to scroll around. However, unlike Khan, you have it all in one place as far as I'm sure he has some advanced optimization examples, but these are all the basic ones. He does examples like the one that we did in class last time with like, hey, there are two numbers, find where this or that is the minimum, this or that is the maximum, etc., etc. He does a couple of those. There's another of like the two numbers. There's another of the two numbers. He does multiple ones of like the algebraic optimization. Somewhere in here, ooh, things change. And now he starts talking about a rectangle and dimensions. You could also think about, hey, didn't I have notes open a second ago? A fence around a rectangular plot of land. He does an example like one of those, which could be specifically helpful for homework. But we're also going to do one of those in class. Oh, there's even a river. He also does one with, oh, interesting, like separate paddocks, like maybe for like a horse pasture. Oh no, these are pens. A farmer. Maybe he's planting stuff. And other examples, they're like trying to, I don't know, separate into different corrals or something. But this is an irregular, it's still a rectangle, but it's irregular because you have multiple fencing. It's not just around, it's also on the inside. So he has one of those. So rectangles, dimensions, ooh. And then he has one that has to do with the closest. With the closest something can be. So the distance formula, that's interesting. And okay, so closest. And then he also might have another closest example. Then he has one about the highest slope, the steepest something can be, the highest slope, which is really helpful. He also has a shape within a shape, trying to find the biggest rectangle that can be enclosed within a curve. And I think that's probably his last one because that's kind of an intense one. Okay. I just showed you a few examples of what Organic Chemistry Tutor can provide. Those of you guys that did Khan, actually, Lucas, compare, contrast. So then what's nice about Khan Academy? Pros and cons. You can say pros and cons.
CalcAB, again, the explanations were really nice. It was kind of more, I guess, simple explanations than the
like more straightforward, kind of?
Yeah. Like, it wasn't as complicated problems that they were doing, and it was a lot, the actual problems that they were doing were a lot different than the organic chemistry tutor, so it's kind of like a different...
It's a whole different experience, sort of. Was it more specifically helpful for the problems that you guys had in your practice set?
No.
I was wondering. For instance, well, I mean, both of them, I hope and I assume, organic chemistry started, the OChem tutor guy, he started with positive numbers or two numbers, and he had 3 of those examples. Like, that's the first problem that popped up for me, and I think you guys all had the same problem set. Is this the same one that popped up for you first, those of you that tried it? No. Well, that's annoying. And I just closed down the manage, which is what I could have gotten from here. Can I get to your actual problem set? I should be able to. Let me try one more time. Here and then here. Well, it changes for you so that you are being challenged and you don't just like go back and put the letters that you know are right. You know what I mean? So it changes for you, but everybody should have started the same place. Does that make sense? So I didn't make it to where you guys all had different ones to begin with. You guys should have all had the same first iteration, and then if you did it again or again, like it would change it up for you. Is the idea anyway. No, that pops up to that. Where was I a second ago where I got to see it all? Was it responses? Was this your first one with a triangle? Ooh, which was like the very last one in OChem Tutor. But you're right, wouldn't be like the immediate ones in Khan. You would have to think of sum of squares, box volume, profit, cost. Probably you would want to go in here to the area ones for the area. But let's pause. I have Khan open, I have Khan ready, but let's go to our Jamboard and let's just talk about the big picture of optimization. Is that cool? Let's take some notes on the big picture before we just jump back into problems. But I have Khan Academy ready to open and help you guys on. I have WebAssign ready to get into if maybe we need an example or we want to go find a WebAssign example and not just do one of the ones from notes. And that's where we originally would have done it, but I thought that was a better way to give you guys some homework over the weekend, some exposure. Yeah, there was the Khan practice. It was different than last time, but I think it's because I reassigned it. They like that volume one first for some reason, or for you guys, the area one first. Okay, big idea. Big idea. Did we take these notes last time, yes or no? think we started them. We just didn't talk about them. Do you have them written down? Cool. Cool. So we have them written down, we just don't have them totally processed yet. So let me make it big so everybody can see it. People online, I think I have to change my screen share. There you go. But otherwise, happy Monday. All the logistics and things we've already talked about. We already prayed for the day. Those of you guys that came in a little bit later. I will get coffee. Let me go get my water. Okay, do you remember? We listened to the intro of OChem Tutor, right? I think when we listened to the OChem Tutor, what were you guys all laughing about with his description of optimization? Optimization problems. They're the ones where you try to optimize. Hey, you're texting. That's fun. Optimize. You're trying to think of what to respond. It's a lengthy one, so it's going to take time anyway. Just put it to sleep. You can think about it as we go through class. It's a dumb explanation. Optimization. Trying to optimize something. But what was the other word that was an adjective that had to do with that root word that I thought was more helpful? Optimization. It means to optimize. You're trying to find the what? Yes, you are trying to maximize, minimize. Yes. Usually not both. Usually one or the other, because you're trying to find what kind of solution, and it actually has part of this word in it as the adjective. Optimal. You're trying to find the optimal solution. So yes, I know it's silly. Optimization, you're trying to optimize. What does that mean? Finding the optimal solution. What's the optimal solution? Well, if you're trying to, as a business, find a solution or aim for a certain goal with profit, wouldn't you optimally want that maximized? Right? Cost, you would optimally want that minimized. So it depends, right? It depends. If you're trying to get seats to, I don't know, like your favorite sports team or like your favorite artist concert, optimally you want to be closer, right? If you're trying to pick the optimal seat in the room compared to the most annoying person to you, optimally you probably want to be farthest from them, right? Etc. So the idea is sometimes you want the highest, sometimes you want the lowest, sometimes you want the closest, sometimes you want the farthest, sometimes you want the most, sometimes you want the least. And behind all of these words is the idea of maximum or minimum. And why does that require calculus? Well, because that's what derivatives are. It's not the only thing derivatives are good for, but it is one of the key applications of differentiation. How do we find critical numbers? No. How do we I gave it away. How do we find the possible extrema? Yeah, critical numbers. I want to get rid of that. Thank you. Okay, there we go. So where are we at? Technically, this stuff is going to be, ready, green pen trick. Why do I call it the green pen trick? Because green I use for pre-cal stuff. It's review. Someone tell me something that you learned before calculus in math. There's so many different.
Addition.
What? Addition. What else? Huh? Subtraction. Oh, let's keep it going. Geometry. Keep it going. Study things like area and volume formulas and Pythagorean theorem and, I don't know, SOHCAHTOA, CHOCHOCAO. It began in geometry. What else? Think algebra. Come on. There's a lot of algebra stuff.
Quadratic formula.
Yeah, quadratic formula, or before that, factoring. Both, either complete the square. What else?
Distance formula.
Distance formula, midpoint formula. Yep. What else? Domain. Oh, range. Oh, point slope. Nice. We use that for tangent lines. Slope formula. Y2 minus Y1 over X2 minus X1. Average rate of change. Also, change in Y's over change in X's, or change in functions over change in. That's impossible. It's not. I'm just lazy. And it's not necessary right now. Let's see. What else? You technically didn't say multiplication or division, but I'm assuming we know that. How to work with fractions. How to work with percentages. How to do, polynomial long division? Slant asymptotes. How to reduce common factors, how to solve for zeros, how to factor in general, how to do like all of trigonometry, just kidding, not all, but some, imaginary numbers and how they're not really going to be there, so anything with the square root of a, wait, when's imaginary happen? Square root of a negative 1 or negative anything, that's not going to really be on a graph. What else? Polar parametric, we barely did that. It depends on whether you were in honors or not. Matrices, we're definitely not doing that this year. Although that gets interesting in a college class for engineers called linear algebra and computer scientists. I don't know. Okay, so green pen trick could be any of that, which is unit circle. Complex fractions. Okay, so when I put green up here, identifying all givens and what needs to be found and or draw a picture, even though in calculus you're going to get hopefully more used to this process, technically that's just reading and translating and figuring out the goal. Does that make sense? Taking a problem, trying to express it mathematically, think good old-fashioned word problem. Can I take what's been given and can I delineate? Can I map out all of my givens and what needs to be found? Technically, even this one is going to be not needing calculus. It's just identifying where is that max-min idea. What is optimally being looked for? What is optimal in whatever situation? What is optimally happening in whatever situation? No. What optimal solution are you seeking to find? And do you have variables for those quantities yet? That should happen here. If it hasn't happened here, at least you'll know here. You're still identifying what needs to be found. Do you want to find the max? Do you want to find the min? This one, I don't know. I'm going to put in parentheses. It is technically still green because you're still identifying stuff. You're still translating stuff. You haven't done any calculus yet. But in the midst of the green, I should probably pick a new cartoon or a new animated film or a series, because most of you guys probably didn't grow up with this, but it works really well for the context. What am I alluding to? Oh, okay, a few of us still know. Question. What did Blue put in his handy-dandy notebook? What did he put in his handy-dandy notebook? What were the Blue's clues? The notes, the clues that he would pick up all around in the episode, right? And he would take that clue and he would put it in his handy-dandy notebook, and then usually there was some sort of, problem to be solved or some sort of question to be answered or some sort of item to be found. I don't know, whatever. At the end of the episode, obviously I watched like 2 of them. But anyway, either way, when I was like babysitting or something. That's about all I got. Anyway, and then one of them went to jail. So coming back. Was it Steve? Just kidding. Everything is awesome. Okay, so new movie. The idea is there's some sort of hidden, usually the secondary equation, it's not specifically this goal. It's not specifically this quantity that you're wanting the max or min of. It's something additional. It's an additional constraint. You only have this much money, or you only bought this much fencing, or you only have this much space, or the can has to hold this much liquid. It's some additional fact that we're not going to use immediately, or sometimes we do use it immediately, but it's secondary to the primary goal. That's the best way to put it. This bottom one, number 4, towards the bottom. Check the feasible domain. We're just trying to ask ourselves open or closed, basically. And somewhat think about, in this situation, it's rarely going to be possible to have like numbers negative infinity to infinity. It's a real life problem. There's some sort of constraint that should be placed upon it. But we're asking ourselves open or closed for the reason being open. If it's open, all we need to do is basically a first derivative sign chart. Usually is the easiest way to go. for finding our relative min or max. Closed, we're going to have to consider an absolute extrema, which means we're going to have to test, if you guys remember from your from your forever card, sorry. Test critical numbers and endpoints. If you guys notice, we did not do our first things first forevers this morning. I did not have you line around the room if people are home because they're skipping that. When you come back. It just was going to be too weird with people on Zoom and people here. And I know they all had other reasons for being gone. But still. Okay. Hopefully you still studied your forever cards, though. So this is just kind of mapping out, are we feasible domain? What would make sense? Like, what kinds of numbers are we looking for? Would an answer of 500 make sense, or would it not make sense? Just getting, like, intuition in the problem, and then kind of knowing, wait, are we going for a first derivative sign chart, or are we going for critical numbers and endpoints? It kind of just, like, charts the course. And then finally, we get to, hey, let's use all of that 3.1 to 3.5 skills of getting that relative max or that relative min. You guys already had most of that written in your notes. Sorry, I need that screen to disappear. There we go. So let's just do a quick recap review. And in context, let's say our primary goal is to, I don't know, what do you guys want? Do you want a max or a min? What do you think our goal should be? Of some completely arbitrary, who knows what the example is. What would you rather, max or min? Max, okay. So we're trying to maximize arbitrary goal. I'm just going to call it A of, and we'll just use X because why not? That's like our easiest thing ever. However, this could also be like the area of something. Area. We always want it in terms of one variable. This might take some work. When I say get a representation of the rate of the derivative, once we figure out our primary goal, let's just say this, maximize A. To do that, even though we have implicit differentiation, we want in terms of one variable. So say we're doing area and there's length times width, or x times y. We really want it just with x's, or we really want it just with y's. I'm saying need, I probably should be saying want. It makes the calculus so much easier. If we have implicit differentiation, that would be like a level above where we are right now. So we need or we want it in terms of one variable, if at all possible. Once we have it in terms of one variable, which usually takes us using the clue. Oh, that's a bad blues clue. Let's answer, and I'll do some shading in that one for you, right? Okay. We usually need to use the clue in order to get it in terms of one variable. Once we have that, perfect. Now we can go ahead and, if necessary, if they don't give us the derivative, then we're going to find it ourselves. Find the A prime. Once we have the A prime, remember that we're going to go ahead and look for our zeros and our undefines of our A prime of x that has probably a numerator denominator, not always, but sometimes. If it doesn't have a denominator, don't stress about this guy. If it does have a denominator, look there. Quick recap, quick review. Critical numbers cannot be discontinuities. Remember, critical numbers cannot be discontinuities. So ignoring discontinuities, those are not possible extrema. But do remember that our critical numbers are our possible relative extrema. Not actual, we have to see sign changes, but our possible relative extrema. And then we test candidates, crits or endpoints, if we're looking at a closed interval or a closed domain, or first derivative sign chart. I forgot I had this page, so if you already wrote this, you might not need to again. But if we have some sort of open domain, and so quick reminders of that. Remember, for testing the critical numbers and or the endpoints, we're throwing those special x's into our original quantity, not our derivative. We have our a, whatever the beginning, we have our b, whatever the end, we have whatever critical numbers we found from the calculus in between. And then we're literally just testing, hey, what happens when we plug into the original each of these, and we're looking for the highest or the lowest, whatever the context is of whatever you're trying to find. In this case, we were trying to find the max or min. We were trying to find the max, so we'd be trying to find the highest one. But the calculus is all gone by the time we get to this plug-in step. Calculus found us the critical numbers, and then we just plug in those with the endpoints and look for the highest. So in context, highest would win this question of, hey, where is A maximized? Or what is the maximum value of A? But sign chart, a little bit different, right? Sign chart, a little bit different. We're assuming it's open, so maybe negative infinity to infinity, or maybe it is an A to B, but it's something where it can't actually be A, because A would be 0. And you would never have a rectangular field with a width of 0, because if you did, it wouldn't be a field anymore. It would just be a random fence in the middle of nowhere. That's not enclosing anything. So if 0 is the lowest, usually that's not really possible, so it'd be open. Maybe on the other end, the highest it could be would use all the fencing, and so the other guy would be 0, which isn't really practical. I'm making up stuff. Actually, I'm not. I'm using real problem examples, but it feels really arbitrary to you guys right now. But we would throw that critical number or any critical numbers inside. We would test in our first derivative. And we're looking for that positive to negative in order to be able to say, hey, that is our maximum. Now here's the crazy thing. In a lot of these problems, you're only going to be finding one critical number, and if all of your math is right, this will happen and become what you want it to become every time. This is a step some people start skipping. The dangerous thing is in skipping it, even though usually you'll be okay in the problem because there was only one crit, and so it's bound to be the right answer. It'll just bite you in the butt in a trickier problem, if that makes sense. But this is a skip that technically a lot of people, this one right here with the first derivative sign chart, a lot of people just start skipping, but it's still technically important to what's going on. So here's the crazy thing. Where do these problems get hard? Let me get my laser pointer for people online. This is technically review. This is technically review. This, okay, the derivative can be messy, the simplifying and getting crit can be messy, but this is technically review. Where does it get hard? Ironically, usually the setup is what's hardest. Ironically, usually the setup is what's hardest, which is why I at least wanted you guys watching some examples online, even if you didn't finish all of CalcAB, which is why it's like, no problem, no stress. Let's make it 11:59. Let's go over CalcAB questions in a second. But I wanted you listening. I wanted you watching. I wanted you now. The slight dilemma is if you're like, this isn't the problem that I need, and so you just like, we're looking at all these little blips of videos and not actually watching any. That's a little dangerous. More texting. But he knew his response. He did it quick, sent it, and then sleep. This was the one we did last time. Remember, Jamboard's up. Go to slide 2 if you need any of that. This one was a little awkward because this one wanted the max and the min. Do you see that wording here at the very bottom where it said as small as and as large as? Usually it's only asking for one. This one asked for both. All right. What is as small as? What is as large as? I read this wrong in class last time. We had to look back and say, what immediately precedes this? What came right before? Is. Well, that's not helpful. Reciprocal. Okay, no. This was all a prepositional phrase. A prepositional phrase that was descriptive of what noun? The sum. Yeah, think about English. Reciprocal and a number was all what was happening inside of the sum. The sum was supposed to be as small and as large. Primary goal. Primary goal was to maximize or minimize. See, I identified the primary goal. And technically it was both. We wanted to do both to the sum. Who's the sum? I called it S. S of what? Well, I don't know. We got to put variables in. Fine. Call the number X. Cool. So the sum of the number X. Cool. And plus, it's reciprocal. Oh, hey, it was in terms of X. Gorgeous. If it's in terms of X, take it over here. Take its derivative. Find its critical numbers. Ta-da! And then what was this? Well, it had two options. It was either this guy or it's that guy. Most of you notice it's that guy. So what kind of domain must we have had? And did we? Yes, indeed we did. A closed domain sent me to a table, sent me to taking the endpoints and picking the only critical number that fit in between. And then I plugged in, chugged, plugged in, chugged, plugged in, chugged. The lowest one was 2. So it's asking for find, who are we finding? The number. So we're not answering with how high or how low that sum goes. We're answering with the number itself. So 1 is the location of the lowest the sum can go, which is 2. And 1/2 is the location. I think 1.5 plus 0.66666 would be 2.1666. Yeah. So let's set it up. I think I have down here somewhere a blank. Do I have one? Yeah, here he is. Let's steal him. What can you guys fill in? Okay, what can you fill in? Oh, come on. You got one here already. What can you fill in? Give me some. Oh, my boys on the side, make sure you're focused. I'm really letting you guys sit next to each other, but encourage each other in what's right and good. Someone tell me an important word. It's hard to go straight to the blank. Tell me an important word up here. Give me one.
Product.
Yep. I wonder why she's making it blue. Tell me something else.
Sum.
What kind of sum?
The first plus 3 times the second.
Why am I putting it in parentheses? That's a prepositional phrase that is describing, right? The sum. Are we okay? Which sum? This sum. Okay, cool. What about the sum? Who's my primary? No, I'm not trying to maximize. You just read it. What am I trying to do? Minimize who or what? The sum. Which sum? Well, I want S of X, but I'm not sure I have that yet, so hold on. Okay, so what is the sum? Sum of what? Let's get to that prepositional phrase. Sum of oh, there are 2 numbers? Stink. All right, well, we're going to call one X. I mean, I would, because I like X in my equations. But if I have a second number, what am I going to call that?
Y.
Yeah, sure. I mean, call it A and B. X and Y is a little easier. How we doing so far? Just give me a thumbs up if you're like, yeah, okay, I'm tracking. We're reading. Making an X, making a Y. Cool. So the first, all right, call him X. Cool. And then 3 times the second. Why is that annoying though? I want S in terms of what? One variable. It's in terms of 2. But what did we write in the notes that we should go back and look for? Look for, there's an extra piece of information. What's that extra piece of information? The product x times y is equal to 48. Oh. With the clue, could I maybe do a substitution to get rid of the y and make it in terms of x? Yes, and that's called pre-count. I'm just making it blue because of Blue's Clues. But can't I solve for y and say, I'm going to get rid of you, right? We can make it look a little bit nicer. Maybe I'll just wait to get to the final form. This is all pre-cal, just keep it here. X plus 3 times 48, remember that'd be 3 over 1 times 48 over x. So, any mental mathers out there? 3 times 48?
144.
144, close. Because 3 times 8 is 24, carry the 2, 12 and 2. Or you can think of 3 times 40 is 120, 3 times 8 is 24, 120 and 120, and 24 is 144. It's in terms of x, cool kids. We got him. Wait a minute. But what are we supposed to do once we have him? Why? Because what are we supposed to be doing? Minimizing, which means find the minimum, which we need critical numbers for. Are we okay? Cool. Why did I rewrite it? Because it's easier to take the derivative. What am I about to do? Take that derivative. Derivative of x? Derivative of, it's your homework problem. Come on. Derivative of the next one. Which is exactly the same thing as, how do we do critical numbers again? Yeah, but what about the DNE? Are you guys cool if I do a little pre-cal of just getting a nice fraction from my pitchfork? It's usually safer. As you do homework, what was that, Lucas? Was that 3.5 or was that Josh? Where if you didn't make it a fraction, then you might lose one of the critical numbers. That might have been you. Josh, was that you? But if you don't make it a common denominator fraction, you might lose some of those crits. But do you guys see that my crits are going to be at 0 and plus or minus 12? Are we okay? Zeros are at plus or minus 12. Plus or minus square root of 144. X plus 12, x minus 12. 0 comes from the bottom. But why am I going to come back and circle this? Pre-cal, I'm just reading the problem. I'm going to say no to that. What was my domain? What's the lowest x can go? What's the lowest x and y technically can both go to still be positive? What's the highest it can go? Oh, struggle bus. Positive infinity. Yeah, I can go however high. Positive numbers, I mean, 1 trillion is a positive number. There's nothing stopping how high it goes. Well, except for this whole 48 thing. But technically, 1 trillion times 48 over a trillion is 48. That's okay. But how low can a positive number go? But what about a half? But that's exactly, you're like, I want to stop it at 1. But no, what about a half? Or what about a third? Or what about 1 over square root of 2? All of those are positive. So I have to go to 0, but say, but not 0. I go to 0, but I say, but not 0. Because 0 is neither positive nor negative. So guys, what am I doing? Am I doing an absolute extrema table, or am I doing a sign chart, technically to prove? If I have an open interval, am I testing endpoints in a table with the critical numbers, or am I doing a sign chart? Good, 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 good. So we're doing a sign chart and my sign chart. But pause, look at your notes, guys. That should have been something where you could go to your notes and you could look at the two options. Have we made our notes a good resource for this section? Right back here. Test or first derivative sign chart. Table or sign chart. Have you somehow marked this out to yourselves about if it's a closed domain, go to the table. If it's an open domain, go to the sign chart. Okay, that's going to help you. Have it. Make your notes your best resource, or at least a resource. First derivative sign chart, I'm going from 0 to infinity. So which of those critical numbers actually even apply in this context? Only the 12. If we've done all of our math right, and I'm looking for a minimum, 12 has to be the answer. It's either 12 or it's none. So we're going to assume it's 12. Some people would skip this step entirely, but if you're actually showing that it's a min. If there were more than one, we'd have to do the full analysis. If there's only one, you've done your math right, it's multiple choice, the AP timer's going. Pick the 12, it's it. But otherwise, to prove it, and to make sure our math is right without looking at everything, we can go ahead and plug into our first derivative something like 10. 100 minus 144 is a negative number. Plug in something like 20. 400 minus 144 is a positive number. Squareds are always positive. I ignored those to get all together. Where the first derivative is negative, the function is doing what? Going down, aka decreasing is the snazzy math term, and where the derivative is positive, the function is, whew, that was a little rough. So therefore, my final answer is 12 and 4. Would you have gotten both of those as your final answers in web assignment? Ugh, I solved one for you, you guys. What did I have to do to know that my final answer is 4 and 12? If they ask for the smallest and the biggest, you're going to put 4 in one box and 12 in the other box. But what question am I answering, guys? Exactly. You had to make your way back to the very beginning of the problem to say, oh, I was supposed to find both numbers. What numbers? Those numbers. But you only have, yes, you have x is equal to 12. So what did I have to do in order to find y? Plug it into the clue. Plug it into the clue. And 48 divided by 12 is equal to, do you see where I got it? I got the 12 from my sign chart. I went ahead and plugged it back into my clue to find my y, and then I had both my numbers, and I'm done. If you guys didn't notice, on WebAssign, people online, I can change you over there. The first couple numbers were, the first couple problems have to do with numbers. And then it gets to rectangles, and then it gets to closest. Oh my goodness, OChem tutor. Gonna come in, clutch. More rectangle with a river. Oh, OChem tutor knows how to do that. And then there's something to do with the right triangle. I don't know what's going on there. And then we have, ooh, but it walks me through all the different steps. And then something about OChem tutor, a shape within a shape. And then it has, okay, so OChem tutor might be a good thing to look at, yeah? Coming back. So let's talk about a rectangle. Let me see. I want to take like maybe 5-10 more minutes on this, then go to con for the rest of class. Is that cool? Let's do maybe 5-10 more minutes and then to con. I might save that Desmos thing until after we take the quiz. So maybe until next Wednesday. All right, cool kids. OChem tutor does a rectangle example. Our book does a rectangle example. Con might do a rectangle example. I don't know. OChem tutor is kind of following more of a traditional textbook. Con is kind of making up his own way as he goes. With a lot of informed perspective, of course. Who can tell me whether we're maximizing or minimizing? That's all I'm asking. That's all I'm asking. Max or min?
Maximize.
Why?
Whatever the greatest.
Did you find it? Now, some of you are trying to read the whole paragraph. What did other people do? Yeah. And I mean, just from my like troubleshooting mathematical, I found the question mark and worked backwards, right? Question mark is the question. What are you trying to do? Dimensions of greatest area. Oh, greatest. Is it good to read the whole thing? Yes. Use your reading comprehension skills. But, yes, exactly, greatest area. So not only do I know, oh hey, not only do we know that, but what else can we answer? What are we maximizing? Yeah. Okay. Area of what? Well, okay, work your way backwards. What are we talking about?
Rectangular.
Sweet. Does it say anything about a river or some body of water that's like, I only need to fence in part of it? The answer is no. I'm just warning you there are others where the answer is yes. So it's a rectangle. Why is it a rectangle? A regular field that's just being fenced in on every single side. Cool. I'm going to make x the, what would you guys call that? The length, and then this is the width, right? X is the length, y is the width. So if that's the case, go back to pre-cal, aka everything before calculus. What's the area of a rectangle? AKA in this context. But why is it a, aw shucks? What do I want? Only with x. So what do I go looking for? What else is here? We've dealt with a rectangular plot of land. Fenced in, okay, fine, whatever there's fencing. Using two kinds of fencing. Oh, interesting, okay, whatever. Two opposite sides will be heavy duty. Let's see, maybe this one's heavy duty because it's exposed, and this one's heavy duty. But maybe this one's like next to a building, so it's not a big deal. Or you trust the neighbors on that side. I don't know. Whatever. These ones aren't heavy duty, but these ones are. I mean, that's cool and all, whatever. So I guess the X's are going to be $3 a foot. Per foot. Per in math is multiplied. The Y's are going to be $2 a foot. I'm not talking about size anymore. I'm talking about cost, right, guys? What else do you see? What haven't we dealt with yet? Of? There's my constraint. I only have $6,000. That's all I got. How are we doing? It's a little more hidden than last time, right? Last time was, well, there's nothing else in the problem, but the product is 48. This time it's like, oh, they're telling me about fencing and saying this is one type and the other is the other type. And then all of a sudden it's like at the very end, P.S. you only have $6,000. Oh, isn't that limiting? Right? So what did we do last time? WebAssign problem. When we had this sum guy, but we had two variables and we had to, oh, we used this to substitute. Victor was saying it's substitution. So what are we going to do this time? Substitution. What do I want to get rid of? This guy. So what am I going to solve for? This guy, right? Any of you guys algebra wizards? Can you do all the algebra real quick for us? What's going to happen when you get y by itself?
6,000 minus 3.
I mean, depending on, I guess I could break that up and maybe we'll just plug them in. Make it simpler, and then if we want to, we can rewrite it for a derivative. So A is equal to x times 6,000 minus 3x all over 2. Couldn't I also make that, I'm not sure if it'd be easier or harder. I think to rewrite, I would go ahead and do 1/2 6,000x minus 3x squared. That looks a little bit easier to me. That dividing by 2 is really a multiplication. Think of what's in front of the x, so 1 over 2. And then if you want, you could even keep going and say it's the same thing as 3,000x. Why am I rewriting? Because what do I have to do in the next step, cool kids? And the derivative might be a lot easier if I just have it written instead of a quotient rule, something. But yeah, let's go ahead and get that area in terms of only one variable using that extra constraint. And then let's go ahead and take a derivative, which is equal to 3,000 minus, bring down the 2, the half cancels, 3x. What was the purpose of taking a derivative? Oh, to find our crit. And there's no denominator, so I can just find the 0, right? So then wouldn't that be at x is equal to 3,000? Negative 3,000 over negative 3, but whatever the negatives reduce. Oh wait, what is 3,000 over 3? Reduce. The 3 over 3 becomes a 3 times 1,000 is 3,000. It's okay, that just shows you how much of a struggle it is this morning. Okay, so that's 1,000. Oh, stink. Do we do a table or do we do a sign chart? What have we not thought about? Yeah. How do we know which one's which? We got to think about closed domain or open domain. Closed domain, we have $6,000. $6,000. What if you didn't listen to your boss and you spent all of your money on the heavy duty fencing? You spent all of your money on heavy duty fencing. So you spent all $6,000 right here. Then you would be buying 2,000 feet, right? Of the wrong kind of fencing. So 2,000 is the biggest, if I was thinking about X. 2,000 is the most I could get. The question, are you going to actually be able to build this rectangular if you spent all your money on the X? No, so that's going to be open. Like, you better not do that. That's a bad idea. You can spend up to $2,000, but then you aren't going to have any money for this guy. What if you spend all of the $6,000 on the regular fencing? Well, that would be telling us how big Y can go. We don't really care about that, but what I was showing you is if you spent all $6,000 there, what's the smallest X can be? If you spend all the money here, you're not going to have any X. Does that make sense? But I'm going to make that open and be like, no, I need both fencing. So X, the heavy-duty fencing, well, I should say X, the dimension. Because of my money constraints, I can't make this any longer than 2,000, and I can't make it any shorter than 0. Well, I'm not even going to make it 0. It's somewhere in between 0 and 2,000. Like, I'm kind of playing dumb a little bit. Like, what if you spend all the money here, you only have this much? I can't go beyond 2,000, but it better be less. That's just giving me some sort of idea, but still, guys, the main point is this is an open interval, right? Since it's open, what are we doing? Sign chart or table? Sign chart. So it's not going to go below 0. It's not going to go above 2,000 because I only have $6,000, and if I forgot him, that's the most I could buy. What's nice about checking domain is this plausible? Yeah, 1,000 is plausible. That makes sense. Hey, that's halfway in between. I wonder if that's sometimes a thing. Sorry, I put f prime for function prime. Technically, we're doing area prime, right? If I plug in something like 10 to my derivative, 3,000 minus 30, that's a positive number. If I plug in something like 1,500, that's bigger than 3,000. Which is exactly what I was hoping for. Once again, why some people start skipping this step, because these problems are fairly basic. And so you're usually, as long as your math is correct, finding the proper critical number at which my answer can be found. Wait, what answer? Hold on, what's WebAssign going to be asking me to plug in? Be careful, they love to mark things wrong if you don't read it carefully. What's the actual question?
What are the dimensions?
So they want x by y, they want how long, how wide. They want how long, how wide. We know, what did we solve for? X, right? X was the guy all along. X is 1,000. X is 1,000. Y, I have to, what did we do last time when we had one but not the other? Do you remember? Oh yeah, we took him, we plugged it in to wherever the clue was, and then we got the other guy. So we can take him and we can plug him into, oh, there he is. So we spend $3,000, 3 times 1,000, remember that back here? We spend $3,000 here. So 6,000 take away 3,000 is 3,000. We have 3,000 to spend here. Oh, so y would be 1,500, right guys? You plug and chug. So we would have 3 times 1,000 plus 2 times, I don't know, equals 6,000. At the end of the day, y is equal to 3,000 cut in half, which is 1,500. So between those two, and careful, feet. Feet are very different from yards, very different from inches, very different from miles. How are we doing?
How is that X smaller than Y?
I just drew a random picture.
So,
A rectangle, I knew one side had to be longer than another. Right? But remember, X is the one tied to the heavy-duty fencing. Y is the one tied to the standard fencing. So to maximize the situation, to maximize the area. Yeah, to maximize the area with the amount of money that you have, it probably makes sense that you would spend less on the heavy-duty. Does that make sense? It's kind of like let's see, in geometry. It's like, solve the triangle, and I put like a 5 and a 2 and a 7. Find angle A. That's not 5, that's not 2, that's not 7. I'm just drawing a basic triangle, and then we're going from there with law of cosines, law of sines. Does that make sense?
Yeah.
So I just drew a generic rectangle, and I just happened to draw it the wrong way. It wasn't wrong to begin with, it was just a don't trust the picture. But so technically what should be happening, that's the basic, and that's the heavy duty, and that one's shorter. Yeah. Sarah.
For the last one we did, how did you know it was in a good interval?
Oh, because 0 is neither positive nor negative.
Oh,
And then, like you said, if it just has to be positive, that can go on forever, so there was nothing stopping. Is that cool? There was this little guy right here. You would think the 48 would stop it. But I said that thing like, hey, if y was a trillion, which is totally, this could be 48 over a trillion, so I can go however high, even, like that 48 doesn't stop me from growing. But the $6,000 stopped me from growing.
so, but if the 6,000, why was it?
This is news.
Guys in the side, guys in the front, Sarah and I are trying to do a quick question conversation. It's a good one. Shh. The $6,000 stops me because if I spend all my money on X, that's the highest it could go, I would have 0 money for Y, so I couldn't actually make a rectangular plot of land.
So is it because
The 0
it's an open?
ruins my rectangle. Yeah, so that's what makes it open. Because I had to have at least a little bit of length but not the 0. So it's really similar kind of to this one, how it had to be at least a little positive, so it couldn't be 0, it had to be a little bit above. But in this one, it was just that case for actually both sides, because all the money spent on X isn't feasible, and none of the money spent on X isn't feasible either. Does that make more sense? Yeah. So that's actually something, guys, that'll be really helpful for all of these that have anything to do with volume, anything to do with area. Your domain is going to probably be a 0 that's open, because it's like, but if it's 0, then I don't have my shape. My shape is ruined. So like 0, could it be 0.1? I guess it'd be a really awkward rectangle, but it would be a rectangle. It just won't be a rectangle with very much area. But it can't be 0, so I keep it open. For most of yours, to be honest, most of yours are going to be sign charts. The only time it's not going to be a sign chart that I've seen is when they say one of these at the very beginning and it's closed. If you guys noticed, there was another problem having to do with 2 positive numbers. Oh wait, that's the same one? No, that's a little different. But we did a WebAssign example that's super similar, so I'm going to go ahead and move this and say, oh, but we did the WebAssign one instead. That was just like it. Then there's a volume one. That's a little bit crazy. But I think if I go look at your guys' homework, I don't think you guys had any volume. You have elk. You have a shape within a shape. You have rectangle. You have, closest. You have area, 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 area. So let's, we'll skip for now the volume one. Oh, it's such a good problem too, for lots of reasons. But we'll skip for now the volume one, because that's not in context of, unless somebody in their CalcAB had volume, but I don't think you had volume. Let's go look at our CalcAB. CalcAB, your very first one was a triangle problem. Nope, that's not the very first one. That's the very first one. Yeah. Okay. So in your CalcAB practice, let me go ahead and throw in the triangle. And let's see if we can use my system for the CalcAB practice. Okay? So you're given a generic triangle, although they probably, because they have very cool systems and programs they're using to do this sort of thing. They probably made these sides like actually accurate to the problem at hand. You might be able to trust their picture, but still, let's be safe and not. They tell me AC is 8. Nice. They tell me that BC is 10. P.S. I think this was your first problem on your CalcAB practice. Looks right? Cool. What am I trying to do? Maximize or minimize? Because?
Largest.
And then look at the whole thing. The largest is inside the prepositional phrase, right? That's a descriptor for area, right? So I'm trying to find the largest rectangle. They're talking about area. I want A of X. But what do I have? Isn't area of a rectangle 1/2? Hey, what's the base? Wait, that's a triangle. I don't get it. Wait, where's the rectangle? Careful. Rectangle. The largest rectangle. That's this guy, right? What? Am I supposed to get a ruler out and figure out where? No. This is an example rectangle. This rectangle is also enclosed. This rectangle is also enclosed. This rectangle is also enclosed. This is one representative rectangle. There could be tons of different rectangles formed by this triangle. So 8 is the base of the triangle, but what's the base of this guy? I don't know. What's the height of this guy? I don't know. Struggle bus. But what's the problem with area being x times y, guys? I want it in terms of one variable. So I want to get rid of this, but the only way to get rid of this is to have something to plug in, and that something to plug in is supposed to come from the what? Clue. Remember how you guys mentioned one of those pre-cal things was geometry? Geometry taught us something about the proportionality of sides sometimes in similar shapes. Or if you like slice altitudes and bases and whatnot of triangles or parallel lines, you have two parallel lines being, anyway, long story short, this whole idea of the 8 to the 10, I know that x and y of the 8 and the 10 I know that x and y are not necessarily the same thing as that 8 and 10, but hold on, what can I say? Do you see how this side of my rectangle is y, and this side of my rectangle is x? And do you see that this side of my rectangle is also a side of a triangle over here? It's the height of that triangle over there. And this guy over here is the base of this triangle. Struggle bus. And do you see that these two triangles are? This was a nasty way for Con to start. It was better last year. These are similar triangles. Telling you, sometimes it's the pre-cal that's the hardest part. What does that mean? That if I think about x to y, and actually I can go ahead and pull this into my clue. X, not because of here, this doesn't mean much, but because it's the base of this triangle that's similar to this one, that's also similar to the whole one. X is going to be to 8 as y is to 10. X in my rectangle, which is also the base of this triangle, this x is proportional to that 8 the same way this y is proportional to that 10. Let me double check my picture real fast. X is to 8 as y is to, oh wait, no, they're different triangles though. Stink-a-dink. Oofda. X is to 8 as this y is to 10. And this this is not a great last example for us to have. Because they're two different shapes. X is to 8. If I were you guys, I would skip this one. Or use your hints on it and then move to another one. Yeah, it's on Con, so you could use your hints on it. This was the very first one. No wonder you guys would have missed the very first one. That's brutal.
Yeah.
Because X is to 8 as A is to 10. And then Y is to 10 as B is to 8. would you have gotten that put together to actually get a nice clue? Well, WebAssign homework might have been easier than CalcAB homework. Just do WebAssign. Oh, this one's so much easier. Why did I do question 1? Okay, what did I say as far as the CalcAB practice? I think I said you had to get like at least 2 right. That's kind of mean, I think, for what the problems that I see are here. So let me go ahead and let's see what are our directions for the one due tonight. Once you attempt, we'll definitely say attempt. Make sure you get at least 1 right. Yeah, you can use your hints and things. I'll just have you get at least 1 right. And include a screenshot of a helpful of a video you watched Con or OChem tutor that you found helpful for this lesson for understanding optimization. The WebAssign examples are more like what I expected. Technically, if I had started at question 2 or 3, I wouldn't have gotten quite so crazy, because 2 and 3 are much more straightforward. 4 is still straightforward, but trickier, and question 1 was brutal because of geometry. Good thing my grad school class in geometry starts today. Yay. Okay. Hey guys, I love y'all. I love y'all. Can you just double check the directions and make sure they make sense? What do I want you to submit to give you full credit for this CalcAB one?
1 question right.
And? Y'all said that you watched some of the video, right? Not the, like, find me. Well, yeah, but what do I mean? Screenshot a portion of a video. So you could have watched OChem Tutor, you could have watched CalcAB when we did this whole voting thing, I think, before you came, Mo. Like, the idea was that you were supposed to go looking for extra help on optimization and get a little feel for it before today. So something from your preferred tutor that has something to do with optimization, just take a quick screen grab or a quick little, like, snapshot of, like, oh, hey, I watched this and it actually kind of made sense. Just get me one of those pictures. Is that cool? Don't record. Don't, like, give me the whole thing. Just give me a quick little, like, hey, this part was interesting or this part was helpful. And in WebAssign, you guys are going to have a problem like the CalcAB problem. Closest. I think I give you one that has to do with closest. OChem Tutor has a closest example. CalcAB seems like it has a closest, at least hints that you can get, right? So maybe just think of that one. Closest is going to be tricky. Hezi and Rocco and Isaac. Closest, look. Stop at your computer, look up here, and if you lose your game, cool. Because you're not supposed to be playing. Closest is hard. So my hint would be for your screen grab is to go find the closest example in OChem Tutor or find the closest example in the CalcAB videos and watch the closest, because I did not get or have time to do that in class. Cool? I'm not requiring it. I'm just saying that's a good idea. Get those 2 things submitted by 11:59 tonight, and you have your CalcAB done, and you can focus on WebAssign, which is rectangular plots of land. Sure, why not? Fencing, and some other problems as well. Noah, what's up, bud?